Hello. What does this tennis racket and tennis ball have to do with machine learning? Well, it's all about sports betting. Sports betting, bookmaker odds, is based on logistic regression. I'm going to teach you logistic regression in this video. When I was in school, I played tennis, but I was on the football team, or what they call in America soccer. I never took much interest in gambling, but my fraternity brothers did, and I learned a little bit about it from them. But I'm going to show you, by looking at the Premier League, sports betting, how this football is related to logistic regression. Most people first encounter logistic regression as a machine learning formula, but there's another way to understand it. A bookmaker setting sports betting odds is actually solving a very similar problem. The bookmaker is trying to estimate probability. What is the probability the home team wins? What is the probability of a draw? What is the probability of an away win? This is what logistic regression does. It converts information into probabilities. The bookmaker gives decimal odds, but odds are really just another way of expressing probability. To convert bookmaker odds into probability, we take 1 divided by the odds. That gives us decimal odds. So if the odds are 1.9, then we had the probability as 1 divided by 1.98 equals 0.505. So the implied probability is about 50%. Now notice something interesting. The probabilities add up to more than 100%. That extra percentage is the bookmaker's profit margin, sometimes called the vig or overround. Okay, now let's connect this to machine learning. Okay, bookmaker looks at features. Things like the goals scored, recent games, the home team advantage, injuries. Okay, this becomes the model's input. Logistic regression works the same way. The model combines those features into a score using the same z equals mx plus b that we use for linear regression and the neural network forward pass. Then it converts that score into a probability using the sigmoid function. If the probability is above 0.5, the model predicts a win. 0.5 is the threshold used by logistic regression. You can think of it as more likely than not. Okay, the payout, how much you make, is simply the stakes, how much you put down, multiplied by the odds. The features matrix. Okay, in machine learning, we organize the input into what's called a features matrix. Okay, each column represents a measurable property. For sports betting, these might include goals scored, recent win-loss record, home team advantage, injuries. Okay, the model is trained on historical values. The bookmaker plugs current values into the model to set the odds for the next game. Okay, if you're not interested in math, you can skip this next section. But if you want to know how it really works, then bear with me a moment. Here we arrive at the central idea behind logistic regression. The model does not really predict probability first. Instead, it models the log odds. Log of p divided by 1 minus p. That expression is called the odds ratio. It's the probability of winning, p divided by the probability of losing, 1 minus p. Then logistic regression takes the algorithm, the logarithm of p divided by 1 minus p, and sets it to our mx plus b formula, right? M is weights, b is bias, x is the football data input, away games, home game, injuries, etc. Okay, this calculates a number between 0 and 1, giving a threshold we can use to forecast a win or a loss. To solve, we take the logarithm of the odds ratio, raise that to the power of e to get rid of the logarithm, then simplify the equation. Okay, this gives us a number between 0 and 1, which is what we need to make a prediction. 0 means no chance at all, and 1 is 100%. Okay, the sigmoid function. Here's a chart of the sigmoid function. As you can see, for large values of mx plus b in the negative direction, it's close to 0. For large values of mx plus b in the positive direction, the function is closer to 1. Those in the middle are our 50-50 threshold, 0 or 1. Okay, the sigmoid compresses all these values into this range. Okay, when dealing with these type of classification problems, win or loss, or even the fanciest large language model, we still use this same basic approach, the same mx plus b. Okay, the pipeline. Now we see the entire machine learning pipeline. Pipeline just means the steps that we follow. Feed in data, do matrix multiplication, make a prediction, check the accuracy, and repeat until we get the minimum error. Okay, error is just the difference between the observed values and the predicted values. For sports betting, that means testing the algorithm against old matches.